Welcome to this fantastic day of algebra learning with Miss Stell.
Today we're going to be learning about multiplying a polynomial by a monomial. So the question I have for you, your essential question is, how does multiplying polynomials compare to multiplying integers? So first couple questions I have for you to get us going is, why is the distributive property used when multiplying the polynomial by a monomial? So that's what we're going to work on. Distributive property should be nothing new. And so the question is, why is it used? Is because when you multiply that monomial times a polynomial, the distributive property ensures that the monomial is multiplied by each term of the polynomial. So again, it's by each term of that polynomial. So when that monomial is not just going to be multiplied by one of the terms of the polynomial, by each. So if it's a monomial times a trinomial, that monomial on the outside with that distributive property will be multiplied times the trinomial 3 times. And the distributive property that you've used for years works for polynomials in the same way it works for real numbers. The second question I'm going to bring up is, how do you multiply monomials that have coefficients, variables, and exponents? So just a kind of reminder, going back to lessons, when you multiply two monomials together, you multiply the coefficients. So for example, let's take 4x to the third power times 5x to the sixth power. You multiply the coefficients. So 4 times 5 is 20. And then you add the exponents of the variable with the same base. So both of these variables have a base of x. So then you're going to, remember, when you're multiplying exponents, you're going to add the exponents. So 3 plus 6 is 9. So that would be x to the 9th. Remember, you keep the x just as the same base. Don't change the base of x, and then add the exponents. So let's get started here. So there's two different ways that you can approach multiplying polynomials. So as we go through these lessons the next couple weeks, you can either choose, if you're a kinesthetic visual learner, you can choose the area model, or some people call it the table, to find the product of polynomials, or you can just multiply it horizontally or vertically. So I will show you on this first example both ways, well, actually all three ways, with a table or area model, vertically and horizontally. But then as you do these, you can choose the best strategy or best method for yourself. So example number 1 here, we have negative 4x cubed, and we're going to multiply that times the trinomial x squared plus 3x minus 4. So an area model, table model, means you're going to make kind of a table here. So this is the kinesthetic. You kind of draw it out. It helps your brain kind of work through it. So how I know how many boxes I need, I always put a multiplication symbol here to remind me that I'm going to be multiplying. I'm going to put the monomial of negative 4x to the third power on my left side box here, and you could put it, you can make this more of a vertical area model. I choose always horizontally, but you can flip it and make the, so for example, you could make it go like this too if you prefer to make it look like this. Put your multiplication symbol here and then put your negative 4x to the third power here. So totally depends on you. I'm just going to show you the horizontal method because that's how I look at it. And then you're going to put that trinomial, so x squared plus 3x and then minus 4. So each term gets its own box. So why it's called the area model, because you're technically, mathematically thinking about, okay, what would be the area of this new box? This is right here. So if I had this side length of negative 4x cubed and this side length of x squared, if I multiply those, because it's a rectangle, it should be able to find me the area of that box. Now, definitely not scaled correctly, but it gives you a quick visual. So remember, you're going to multiply the coefficients. So negative 4 times, of course, this would have 1, so that's negative 4. and then x to the third times x to the second have the same base of x, so I can add the exponent, so it'd be x to the fifth. Okay, to find this area, this side length is 3x, this side length is still that negative 4x to the third power, so negative 4 times 3 is negative 12, and then 4 to the third power, and then, I'm sorry, x to the third power and x, well, they have the same base. This would, of course, have a power of 1, so we can add those together to get x to the fourth power. And then this last area has this length of negative 4. Mathematically, this one has negative 4x to the third power, so we're going to multiply the coefficients. So negative 4 times negative 4 is 16. And then x to the third power, this one doesn't have any, so technically if you really want to write that, it'd be x to the 0 power. Add those together, you still get x to the third power. So my final answer using my area model table model is negative 4x to the fifth minus 12x to the fourth plus 16x to the third. So you just take what's in the boxes and you just write it as a polynomial. Algebraically, I'll use the horizontal method first. So I'll write down the problem. So remember, I talked about on the previous slides that we're going to use the distributive property. So you could think of it like this. So you're going to take negative 4x cubed times that first term of x squared. So technically, algebraically here, that is what you're mathematically doing. And then you're going to take that negative 4x cubed times 3x. So I'm going to add that to negative 4x cubed now times the 3x. So I'm distributing that monomial to that trinomial. And finally, we're going to be taking that negative 4x squared and distributing it to the negative 4. So I'm going to write that down so we can visually see it. So looking at that, notice I distributed every single time the monomial in the front to every single term inside. So what you got left is just to do the algebra. So negative 4 times, again, the coefficient of 1 is negative 4. You're going to add the exponents. 3 plus 2 is 5. And then you're going to go to the next problem. Negative 4 times 3 is negative 12. X to the third power is plus 1x. That would be x to the fourth power. And then the last time, the coefficient is negative 4 times negative 4, which leaves you with a positive 16. And then x to the third, and you can't add it to anything because there's nothing there, so just be x to the third. Notice we get the same exact answers I got above. So it's not going to produce you any different answers. It's just going to be another way to look at it more algebraically without the models. Okay, so we're going to take the trinomial and put that on top because that's bigger. So we're going to have x squared plus 3x minus 4. And we're going to multiply that times, so vertically here is kind of like a traditional multiplication problem, negative 4x to the third power. So it's just like distributing. You're going to, and you distribute all the time when you multiply integers too, you're going to distribute to this first term, the second term, and the third term. So it looks mathematically just like horizontally, it's just more vertically. So we're going to take negative 4x to the third times negative 4, which is positive 16x to the third power. Then we're going to take negative 4x cubed times 3x, which is negative 12x to the fourth power. And this is a positive, so you should throw that positive in there. And then we're going to take that negative 4x to the third times x squared, and we're going to get negative 4x to the fifth. So you can make a decision what type you like. If you're more of the area model, if you can quickly visualize that, or you can solve it algebraically either horizontally or vertically. So let's look at the next problem. So your area model, again, I'm going to draw it horizontally. I'm going to put my monomial on my left side here. So this is 2x squared is what my monomial I'm multiplying. Each term goes in a box, so that would be 5x to the fourth, 3x squared, and negative 4. Just notice and pay attention to the signs. That would make a huge difference on your final answer. So make sure that every sign goes with that term. And then we go ahead and just find the area. So this is a 5x to the fourth times 2x to the second. Multiply the coefficients, make 10. And then we're going to add the exponents, which is 4 plus 2 is 6. Next problem, you're going to take 3x squared times 2x squared. 3 times 2 is 6. You're going to add the exponents, which would be x to the fourth power. And that last one, we're going to take that negative 4 times 2, which gives you negative 8. And there's no exponents to add, so it's just x to the second power. So just write it down the way you see it in the boxes. So it'd be 10x to the 6. And notice that when I write them down, my final answer, they are in the correct form, going from the highest exponent to the lowest exponent. So 10x to the 6th power plus 6x to the 4th power. And that I don't usually do plus and negative, but you can. I just go minus 8x squared. Algebraically, I'm just going to show you with the horizontal method, and the next one I'll do it with the vertical method. So algebraically, I'll write down the problem again for those of you that are going to solve it this way. So go back to that original problem, and then you're just going to distribute. You don't have to do that second step. I'm just going to write it just so it's easier for you to see. A lot of people can just look at it and are not going to write this step, but my visual learners, I will show you step by step how to get this. So 2x squared times 5x to the fourth is my first distributing. Then I'm going to take that 2x squared times that 3x squared. So I'm going to add that in there. And then finally, I'm going to take that 2x squared times that last term, which is negative 4. So then, oops, I forgot to add. So it'd be plus the 2x squared when I'm distributing that monomial times that last term of negative 4. And then go ahead and just do the math. So 2 times 5 is 10. Add the exponents, makes 6. 2 times 3 is 6. Add the exponents, 2 plus 2 is 4. And then 2 times negative 4 is negative 8. And then add the exponent of x to the second power, and nothing to add to that. So again, notice that you get the same answer at the top to the bottom. You can visually see that. Here's that first term, here's that second term, here's that third term. And then also notice that it's kind of this distributing, you can see it in your area model. So you take 2x times the first term, you take 2x times the second term, you take 2x times that third term. So that distributive is also seen in the area model. The last example for today is we're going to have negative 5x times 6x to the fourth power minus 8x to the third power minus 10x to the second power. So back to that area model for those of you that prefer this method. Multiplication symbol, I like to put my monomial here, and then my trinomial, so each term. So 6x to the fourth, negative 8x to the third, and then negative 10x to the second. So we're going to multiply first to get this area. So 6 times negative 5 is negative 30. We have 1x power here. We're going to add that to the 4 there, so we get x to the fifth power. Next box, we're going to take negative 8 times negative 5. That is 40. 3x is here, 1x here, makes an addition problem of getting 4. And the last one is negative 10 and negative 5. Multiply those, you get a positive 50. I have x to the second power. I'm going to add that to the 1 here, so that's x to the third power. So again, it looks just like distributed. It's more of a table model, and it's more of a visual, or for those of you that sometimes are messy in your writing, this gives you a very nice spot to put those final answers. So mathematically here, the final thing is to put them in order. They should be in exponent descending order. Just look at it quickly, 5, 4, and then 3. So we're going to write it negative 30x to the fifth. That's a positive 40x to the fourth, and then that's a positive 50x to the third power. Okay, and we're going to do it the last one. This time algebraically, I'll do it vertically. So I put that trinomial on top because you like to put the bigger termed polynomial on top here. And we're going to multiply it times that negative 5x. Okay, and again, this is just like distributing. It's just a different visual for you. So you're going to take the negative 5x times the negative 10x to the second. So negative 5 times negative 10 is 50. You're going to add the exponents 2, and then remember that's a 1. So that gives you x to the third. You go to the next term. So you're going to take negative 5x, and you're going to distribute to the negative 8x cubed. So negative 5 times negative 8 is a positive 40. X to the first, x to the third, add them together gives you x to the fourth. And that last step, negative 5x times 6x to the fourth. So negative 5 times 6 is negative 30. 1x here, 4x here, makes them 5x's. Now you got to go back and make sure your signs are on there. So I have negative 30x, this term's a positive 40, and that term was a positive. So just add that positive value in there. Have a wonderful rest of your day, and try IXL lesson Z6 to 100. Have a good day.